All right, so I'm going to present a paper joined with Jose Montalban, who is at SOFI. And the paper, it's about the gender gaps in maths and whether the test-taking environment, and I will be clear about what we mean by that, matters to explain why boys do much better at mathematics when they do these kind of tests. But I wanted to start with a more general title for this talk and to give a little bit of an introduction or a motivation for that particular paper. And that's why I've changed the title of the talk, and then I'll come back to the paper. Because really what we're trying to do with that paper is to see the role of stereotypes in the role that stereotypes play in explaining the gender gaps in mathematics performance that we observe in the data. So as a means of introduction, and I'm sure most of you are aware of this fact, is that in most industrialized countries, girls' math results are lower than boys' results. Here I'm going to present somewhat older data for 2015, because this is a nice comparison to the data that we have for our paper. But of course, results hold even in the most recent PISA tests. So the differences are about 9% of a standard deviation on average. So this is, so here we have on the x-axis gender differences in reading, boys minus girls. So we see everything on the left of this vertical red line means are countries where boys outperform girls in reading. And we see that in all countries, girls outperform boys in reading. So we see in all countries, girls do better than boys, okay, in reading. So this is all this area here to the left of the red line, the zero line. When we look at math performance, we observe the opposite. So in most countries above the zero horizontal line, we have the countries where boys outperform girls. So only in the 2015 data, only in Sweden, Korea, and Finland, girls do better at mathematics. So as I was saying before, the OECD average is about 9 percentage points of a standard deviation. In the case of Spain, it's about 15%, and Spain is the country that I'll be talking about today. So we see math gender gaps across a lot of countries, and these are very persistent. Of course, there's lots of work on this. So we know that it seems to be highest at the top of the score distribution. So the gender gaps are higher when we're talking about high achievers. We also know that the math gaps actually increase over a child's lifetime, whereas reading gaps actually diminish. So by the time that boys and girls reach adulthood, those gaps in reading have become zero. However, the gaps in math scores actually increase and remain persistent. Okay, so that is one motivation as well to study math gender gaps. Why do we care? Also, because we know that despite the closing gaps in a lot of labor market indicators and education indicators, we still have gender gaps in mathematics that haven't reversed. So they seem to be quite persistent. We also know that gender gaps, that mathematics skills are quite important for future income. So not only because you select into higher paying occupations if you do math, but also even after controlling by the kind of occupation and the kind of job, jobs that have a higher percentage of math skills are actually higher paying than those that don't. Okay, so these gender gaps in mathematics performance have implications for gender gaps in earnings. And I guess there is an equality and an efficiency argument as well. So under the assumption that men and women share at birth similar distributions of mathematics relevant talents, then the mathematics gender gap is likely to reflect a misallocation of talent. Okay, so it's probably inefficient from an economics point of view. And just to expand a little bit on this argument on you know sort of like questioning this zero sum game. There's been recent, at least in economics, a recent debate or a recent new understanding of what these gender gaps in innate ability really mean and really are. So Marianne Bertrand in her 2020 AEA lecture talked about how in economics we seem to think that men and women are different across a lot of trades. But actually, when you look at the data and when you look at meta-analysis that have been done, for example, Hyde in 2005, you see that these differences are actually quite case sensitive. So they depend a lot on the context. However, when you look at, for example, the whole distributions, differences, in this case, self-esteem or self-confidence on the right-hand side is actually quite similar across men and women. And that is very different to say height or physical differences, where you do observe different distributions between men and women. So this argument that boys may be better at math, it's becoming harder to sustain. So the efficiency argument of what we lose from women not taking math courses are becoming more mainstream in the economics science as well, as a result of these studies on skills differences between men and women. The other development that has happened also quite recently is this notion of the plastic brain, the notion that even if we were to observe differences in the skills, we cannot be sure anymore that these are innate differences or whether they actually are a result of boys and girls being exposed to different environments. Because we know now from neuroscientists that the brain develops in different ways depending on the kind of environment that children face. Okay, so I guess those two recent developments have made a much more stronger case for these math gender gaps being a problem in terms of efficiency, economic efficiency and misallocation of talent. So what I want to do today is to talk about the stereotypes and how stereotypes matter for the gender gap in mathematics. So stereotypes or gender stereotypes in particular are fixed ideas about what someone of a particular gender is like. So this would be, as Marianne Bertrand calls it, descriptive stereotypes, or should be like, and this is more the prescriptive side of the stereotypes. The notion of social norms may fall a little bit into the prescriptive stereotypes area. And this is simply for the mere fact of belonging to a certain gender group. Okay, so that's what we would understand for gender stereotypes. There's quite a bit of work in terms of prescriptive stereotypes and the gender gaps in mathematics. And this is some of my work with Natalia Nollenberger and co-authors, showing that in those countries where women's roles are more traditional, those are the countries where girls do worse in mathematics, okay? And the idea here is that girls anticipate that they're going to have lower opportunities in the labor market in male-dominated fields, so they may shy away from choosing subjects like mathematics, okay? So that's one area of research. A more recent area of research, particularly in economics, has to do with this notion of descriptive stereotypes, the notion or the ingrained idea that boys are better at math because of innate abilities. And some recent research by Michela Carlana showed that more girls that are taught by more stereotypical teachers received advice not to pursue math-intensive subject choices, and also their own confidence lowers in mathematics. Okay, so what we're trying to do in this paper is explore a little bit the notion of gender stereotypes in the context of test-taking environments. Okay, so the research question in my paper with Jose Montalban is to investigate the role of stereotypes when assessing girls' test performance in mathematics in different testing environments. So we're going to be using variation in the testing environment. And we're going to use variation in the testing environment that is going to create a different sort of pressures or different environments that girls and boys may react in a different way, particularly when it comes to mathematics. So I'll explain what we mean by non-familiar environments where the test is externally administered, or familiar environments where the test is internally administered. So those are the sort of variation that we're going to use, and we'll complement our data with some survey data that we collected on self-confidence, on stress, and effort during the test. Okay. So, now going into the paper, we know that girls perform less well in the standardized tests that are competitive in nature. So this is Nuriel Niederle's work. So she started talking about competitive setups or competitive in education, competitive test taking. And we also know that these tests are usually characterized as well by being high stakes, by very tight time constraints, and usually these tests are also usually done in external environments with external evaluators to monitor the examination process. And this is, some of this work has shown that this is particularly so gender gaps appear particularly in male-dominated subjects, like, for example, mathematics. So by male-dominated, what I mean is usually the literature refers to male-dominated in two ways, either when there are more boys than girls, say. That's not what we're doing here. What we mean in this context by male-dominated are subjects where men are thought to be better off or better than girls or than women. So this would be mathematics. So we're going to look at test-taking environments, which are commonplace and important in determining things like high school track or college access. And we worried about the performance in tests, because what we want to measure is actual performance. But if what we are measuring is the reaction or the ability of taking the test, and it has nothing to do with mathematical cognitive ability, then these tests are not really fit for purpose. Okay, so to the extent that there are gender-related responses that make girls to perform less well, not because they don't know any mathematics, but because they get more stressed, or because they have lower expectations and they don't put the effort, then we worry about the ability of these tests to measure mathematical ability. All right, so what are the contributions in this paper, and how does this paper fits into the broader sort of literature? So if we focus on the literature that has looked at different testing environments, we are going to introduce a new source of variation in the testing environments, what we are going to call the familiarity with the test. This has not been looked at before. So the literature has looked at competitive pressure and has looked at pressure from stakes, so high stakes test or low stake test, or also at time pressure. So how girls and boys react in a different way to time pressures, particularly in the test taking in the education setting. The main challenge in this literature when it is outside of the lab is that it is hard to keep other factors constant. So, for example, the literature sometimes mixes up competitiveness and stakes. It's very difficult to isolate the competitiveness of a test, which is when your performance depends on other people's performance. That's when the test is competitive. So it's relative performance as opposed to absolute performance, right? So the more people, the more competitors, the more competitive pressure there is from a high stake or low stake test. So usually more competitive test taking environments are also higher stakes. And the literature has difficulty to isolate all of those in real world setting, okay, which is what we have here. So here, because we're going to exploit a randomized control trial, we're going to be able to keep all those factors constant. And the only thing that is going to change in this context is the familiarity with the test, which is mainly driven by who is invigilating this test. The second contribution of the paper has to do with the external validity of these papers. So we're going to be using population level data for the entire region of Madrid. So this is for an entire cohort of children. And again, another challenge in these papers, looking at how men and women differ when they take tests that have different competitiveness or different stakes, is that it's hard to get samples that are representative of the entire distribution of skills. So for example, the first paper, Jurada and Munich, they look at the Czech university admission system, which is a very, it's already a selected sample of university applicants, right? So it's a higher ability, in a sense, population. The same thing with Ors and Palomino and Pirache. They look at top French business schools, again, the application system and how girls or women and men perform in these application exams. And again, it's a very selective sort of high-skilled applicants. In our case, we're going to have the whole population of students. And the third contribution, and I guess this is the most important and relevant for the stereotypes idea, is that because we collected data, survey data from these students on stress, self-confidence, and effort during the test, we're going to be able to test some of the theories around stereotypes. So one theory is that girls do worse particularly under competitive pressure or under higher stakes or under time constraints, particularly in male-dominated subjects, because of the stereotype threat. Okay, that's one explanation. Basically, the idea here is that girls know that they are worse at mathematics, and when they are put under pressure because of the test-taking environment, they become worried about fulfilling the stereotype that they are worse than boys. So their brain spends time and energy focusing on or being worried about fulfilling the stereotype and not necessarily doing the exam. And this is what actually causes a fulfilling prophecy where girls do worse because they're not, their attention is not on the exam, but actually on this notion of a stereotype. So this is what the stereotype threat explanation is. Another explanation that was that has to do with prescriptive stereotypes is that girls and boys are, they don't necessarily become more nervous or more stressed or threatened by stereotype threat. Instead, what happens is that girls internalize social norms about prescriptive stereotypes. Girls know that they won't succeed in male-dominated subjects. So what they do is they spend less effort doing an exam that is in a subject that is male-dominated, like mathematics. And this is particularly so when they are in high pressure environments like the ones that we will be looking at today. So we will be looking at these two theories that haven't really been addressed. I mean, they have been discussed in the literature, but actually differentiating between this stereotype threat or this effort story is kind of difficult if you don't have the actual data on stress, self-confidence, and effort. And this is what we collected for this paper. All right, so that's a long introduction, so I'll be quick. I have 15 minutes. Is that, yep.
It's okay. I mean, if you need 5 more minutes, it's also okay. It's very, very interesting talk, actually.
All right. Okay, so All right, so I'll give you a little bit of a context of what is the context of this paper. So we're going to focus on the region of Madrid. It's one of the biggest regions, more populated, not geographically big, but very densely populated region in Spain. And we're going to exploit is random variation in this testing environment. So in Madrid in 2015, they introduced a standardized testing. This was as a result of a Spanish law of education, so national law. It was a regional law. And they tested kids in 6th grade and 10th grade. And they tested them on mathematics and then on verbal subjects, English and Spanish. And here you had the form, the tests was a little bit different. So mathematics was all multiple choice. In verbal subjects, there was a written component as well. The duration of the test also varied across the different subjects. In 6th grade, in 10th grade, it was exactly the same, 1 hour. And what we're going to exploit here is this variation that was introduced in 2016 onwards. So in 2015, when they started the standardized testing, the the Madrid regional government implemented this testing externally. So they did it themselves, the authorities. So they hired public school teachers to be the invigilators of all these exams. They also hired markers that were allocated centrally by the authorities, okay, to basically administer all this testing. What happened was that this kind of external administering of testing was kind of expensive. So in 2016 onwards, they decided to have all these tests internally administered by the schools themselves, okay? So the idea was to have invigilators that were teachers from the school where the students were studying, and also the markers were teachers from the school the student was studying. It wasn't the student's main teacher, but it was a teacher from the same school. So this was internally administered, what we call internally administered testing. So it was tested by the school. But what the authorities also wanted to do is to make sure that there wasn't any cheating, moving from the external to the internal administered testing. So they implemented a randomization. So in 2016 onwards, some schools were randomly assigned to the internally administered testing environment, and some others remained with the externally administered testing environment, okay? In both cases, in all the cases, the correction of the test was blind. Okay, so what we're going to argue is that externally administered testing environments are generally more unfamiliar environments that impose higher pressure on students because they don't know the invigilator, they probably don't know much about the test. Whereas in internally administered testing environments, the environment is much more familiar. They are more likely to know the invigilator. They are more likely to have been told about the test because the school has more control of the administration of the test. Okay, so we are going to be using that kind of external variation in the source of familiarity with the test as a way to see whether boys and girls do better or worse in this kind of environments. Okay, so looking at the randomization unit was the school. So in 2015, there was no randomization. In 2016, the randomization happened in some areas. So there are 5 areas in Madrid: north, south, east, and west, and also the capital. So the urban center. So in 2016, there was a randomization in the north, south, east, and west, but not the capital. 2017, it was in the capital, east and west, but not north and south. 2018, the randomization was in the capital, north and south, but not east and west. The idea was that all the areas would get the randomization at least twice. The point of the policy was costs, so to reduce cost of testing. And just to give you an idea, so this is 2016 for grade 6. So these are the distribution of schools. So the capital had no randomization. And in the rest of the areas, we have the red dots are schools with external testing environments. The blue dots are schools with internal testing environments. Okay, so that's how the randomization kind of look like. I'm gonna skip this, and so I'm gonna tell you a little bit about our data. So the main data is this data on test results. So we have the test results for each student at the student level data, and this is population level data. All the students pretty much took this test for all these years, 2015 to 2018. We also have some data on the school characteristics, family questionnaire that not everybody answered, particularly after 2015, when they moved online. So we're going to use family questionnaires for balancing properties, etc., but not necessarily in our analysis. And then the novelty of this paper as well is that we have student questionnaires that we administered ourselves. So right after the test, we asked the students whether they felt stressed, what their confidence with the subject was, and the level of effort that they put before and after and during the test. Okay, and that is what's going to give us a little bit of information on the mechanisms and this role of the stereotypes. So, okay, so that's, so what is the empirical strategy that we're following here? So this is a very simple randomized sort of exercise where the dependent variable is the standardized score in a given subject for the student I in a school S in an administrative district D and in a given academic year T. We're going to have a female dummy. This is going to tell us the differences between boys and girls in this particular subject. We have an external dummy, which tells us how boys do with respect to in external examination settings versus internal examinations. And what we're interested is in this female external, which is going to give us the differential performance of girls with respect to boys in external versus internal examinations. Okay, so that's the empirical strategy. We perform a balancing test, and I'm not going to bore you with this. It's really good that we have the 2015 baseline data where all the exams were external, so we can actually check for each year for the internal and external treatment and control groups. We can check their scores in 2015 in all the subjects, and we don't see any difference between the groups. Okay, and we also do the usual balancing test for the year of the randomization. Okay, so moving quickly onto the results. So this is the main regression results that compares what happens with girls and boys in internal versus externally administered settings. So the top or panel A is students in 6th grade. Panel B is students in 10th grade. So the first thing I would like you to focus on is this female dummy. So the female dummy tells us the gender gap in mathematics or in verbal skills. And here for 6th graders, we see very clearly there is a 15% of a standard deviation difference between girls and boys, with boys overperforming girls. It's the opposite for verbal. So girls overperform boys in 35% of a standard deviation. Okay. When we move to older kids, these are the 15 years old, comparable to PISA students. The math gender gap is about 20%. It has increased from primary to secondary. So this is what I mentioned in the introduction. And the verbal score or gender gap in verbal scores has decreased substantially. So the advantage of girls in reading, Spanish and English in this case, has actually decreased quite a lot. So this is, again, very consistent with what we know about the math gender gap, about the reading gender gap, and the evolution over the life cycle. So the next thing I want you to focus on is this, what happens to this female external coefficient. So what we see is that it is positive in both cases. For mathematics in 6th grade, about 5% of a standard deviation. And in mathematics for 10th grade, about 6% of a standard deviation. Okay, so what this means is that girls in external testing environments do much worse than boys with respect to girls in internal testing environments. And the size of this coefficient is quite big. It adds up to this gender gap quite substantially. Okay, and the interesting thing here is that we don't observe this in verbal. So we don't see that girls do much worse than boys, or much better for that matter, in verbal examinations, depending on this testing environment. Okay, so what we do next is to ask why this is the case. Okay, and of course we want to, before we move to stereotypes as an explanation, we want to rule out certain things. And because I'm running out of time, I'm not going to delve too much on this, but we do check whether these differences come from the fact that girls are being marked in a better way than boys, or in a more advantageous way than boys in externally administered settings, particularly in mathematics, right? So any alternative explanation will have to be something that favors girls in internal examinations in mathematics, okay? And this is what we're trying to rule here. It's not that girls, that marking is different. It's not that girls received more help in mathematics in internal examination settings. It's not a matter of manipulation of the duration of the test in internal settings and in mathematics. Okay, so we do several checks using the different data that we have available, and we can rule out that there is anything going on in terms of marking, the duration of the test, or receiving more help during the test. Okay, so I'm going to skip through that just for the sake of time. I can come back to this. So then what we explore is the role of stereotypes, okay? And in particular, we want to see whether this notion of a stereotype threat and girls becoming more stressed in externally administered testing environments, particularly in mathematics, which is a male-dominated subject, or this social expectation about girls not being able to succeed in male-dominated subjects is something that shows up when you put girls and boys under pressure, when you put girls and boys in externally administered testing environments. Okay, so we collected after for 2017 and 18, we collected data right after the test for each test. So one box that the students had to fill out after they finished their mathematics test or their English or their Spanish were 4 questions about self-perceived stress during the test, about self-confidence overall with the subject, about effort before the test, so how much did they study before the test, and also how much effort they put during the test. Okay, so the effort, so the effort question speak to this social expectation idea, whereas the self-perceived stress speaks to this idea of a stereotype threat. Okay, so these are the answers to the questions, summary statistics, and of course there may be a lot going on here, but remember what we're going to try and do is to see whether these things, these gender differences that we observe here differ by a random shock in terms of how the test is administered, okay? But just to give you an idea of what we see in the raw data, so the left-hand side is mathematics and the right-hand side is verbal, and we see that girls are more nervous in mathematics during the test. They consider themselves worse at the subject. They also studied more, slightly more, and they put more effort during the test, both for mathematics and for English, okay, or Spanish. I mean, one may think, okay, girls do worse historically, so it's normal that they feel more nervous and that they have less confidence, but girls do also better at verbal subjects, and they don't feel more confident on verbal subjects, and they don't feel less nervous when they do these exams, right? So the performance cannot explain everything in these gender differences that we observe in the raw data. There could be a lot of other things going on. And again, we're not interested in explaining these gaps per se. They are very similar in 10th grade. The only difference is that they put much lower efforts both before and after and during the exam, but the gender patterns are very, very similar. So what we do is to see what happens to those differences when we compare girls and boys in the 2 different testing environments. Okay, so this is for 6th grade, and we look at stress, we look at confidence, we look at study prior to the test, and we look at effort during the test. The female dummy is just the gender differences that I showed you at in the summary statistic in the figures here. Well, actually, the figures here, that would be the female dummy. So this is just the same thing. And what we're interested in is in this female external coefficient again. What we see is that girls in 6th grade are much more stressed during the test when they are in externally administered environments, only in mathematics, okay? So that is very much consistent with this notion of stereotype threat for younger girls in 6th grade. Now, the interesting thing is that when we move to 10th graders, the stress is no longer there, but actually what is significant here is the effort during the test. Okay, so girls in 6th grade in externally administered environments put less effort when doing the test than boys. And this is particularly so in externally administered environments. So how do we interpret these findings, and what is really the conclusion of this paper? So just to summarize, compared to internal environments, testing in external environments leads to higher levels of stress during the test for younger girls compared to boys. There is a decrease in effort for girls in 10th grade compared to boys in external environments. And how do we explain this age-related variation? Well, so what we think is that younger girls are probably more susceptible to internalizing gender stereotypes that reinforce the notion of innate differences in mathematical ability. And this is what leads them to become more stressed. However, girls in grade 10 may not necessarily think or internalize this idea that boys are better at mathematics, but they are certainly much more aware of the social constraints that girls faced and women faced in male-dominated subjects. So that's why they spend less effort in the exam when they are put under pressure because of these externally testing environment. Okay, so this is this would be what we conclude for this. So just to finish, almost in time, our results show that girls perform worse in mathematics in external testing environments than boys. This difference is explained by gender differences in stress during the test for younger girls and effort for older girls. The descriptive gender stereotypes that boys are better at math may help explain gender gaps in stress for younger girls. And the prescriptive gender stereotype that girls are not expected to do math may help explain gender gap in effort for older girls. Now, in terms of policy implications, one may think of short-run fixes, fixing the testing model, and these are real interventions that have happened. So, for example, Oxford University increased the time of the test for girls because it was shown that girls with similar abilities to boys did worse under time pressure. Okay, so that's one way of fixing the system. But it's a short-run fix, because in the long run, what we really need to do is to debunk the stereotypes, both conscious and unconscious, prescriptive and descriptives, and to really get rid of these gender differences. And I think that's where policy, but also research is moving towards. How do we change stereotypes? How do we change social norms? There is now a big, I think in economics and other social sciences, there is now a better understanding that before we used to think, for example, that stereotypes, social norms only change very slowly. And recent papers, recent research has shown that actually social norms can change quite rapidly when you have a shock. So Raquel Fernandez, for example, has a paper on the perceptions or social norms around gay rights as a result from the AIDS epidemic. So that is an example where social norms changed quite rapidly as a result of a health shock. Okay, and this is something that is quite new in the literature, and it's sort of changing the narrative and the debates in the literature.